Welcome students to my third lecture of similarity transformation. So last class what we have discussed about the diagonalization. We have understood that what is the condition is required to meet to be diagonalized a given non-diagonal form, and then we have understood how that transformation matrix T can be formed to diagonalize any system, and then we have understood that the application of diagonalization, why we will do the diagonalization. As we have mentioned that diagonalization is easier form because many things can be inferred from the from a diagonal representation of a given system. Okay, now this is the last lecture about the similarity transformation. So quickly we are going to understand that how we can build T matrix to transform any realization to controller canonical form and observer canonical form. So that's why here the problem statement is given. Suppose we have a realization x dot equal to ax plus bu, y equal to cx. Can you build a T matrix such that the above realization can be transformed to controller canonical form, that is x bar dot will be a bar x bar, sorry, here it will be x bar plus b bar into u, y equal to c bar x. Okay, so now you know that how this a bar b bar will look like for controller canonical form. Mind that in controller canonical form a bar b bar is important, they have a fixed form, but c bar do not have any fixed form, they can be anything. Okay, so that's why here what we want that we want to search a T matrix such that we will operate that T matrix on A like this, the T inverse AT, which is my a bar, will look like this, that is 0 1 0 0, and last row is important. They are the coefficient of the characteristics equation. What is the characteristics equation? Now here determinant of Si minus A, we have assumed that this is the characteristics equation. So last row will be minus an minus a minus n minus 1 minus a minus 2, and last element will be minus a1, and B transpose should look like all elements will be 0 and the last element will be 1, and C bar is equal to CT. Do not follow any particular pattern, whatever by calculation it will come, you have to write, but A bar and B bar should look like this for a controller canonical form. Now again the same question can be asked, that why we will do this representation, why this representation is important to us. Okay, because later on the next topic you will find that we are going to discuss about the controller design in state space. At that time you will find that this controller canonical form help you a lot from the point of view of that calculation, because it will, when you will do the controller design and if the system is in a controller canonical form, you will find that at that time controller design will be easier for us. Okay, so now how the next topic is how you can build the T matrix. Here you will find that for this case I am not going to discuss about the proof how we have built the T matrix, only I have discussed here the procedure. You have to remember that one. Okay, so what is the T matrix? Now T is equal to C into M. What the C matrix will look like? Now construct the controllability. C matrix is known as controllability matrix. C will be B A B A square B A n minus 1 into B. So you have to build the C matrix depending on the dimension of the A matrix. It will be B A B. So its dimension will be n cross n. How? Now you see what I told that C will be the controllability matrix. C will be, how the C will be, now it will be B. So what is the dimension of B? B will be n cross 1. Okay, so it is a column vector. So now AB, what will be the AB? So A is n cross n, okay, and B is n cross 1. So ultimately you will get n cross 1. So it is also a column vector. So now if you have the column vector of dimension n by 1, so ultimately you will find that, so n minus 1 into b, that's also will be n by 1, so ultimately will be that controllability matrix will be the dimension of n cross n. Okay, so now this is the C matrix you have to form, and then here one thing you have to remember while you are doing the controllability canonical representation, whether for a given system controller canonical form representation is possible or not. To check that one, that this controllability matrix should have full rank. Okay, this controllability matrix should have full rank, means the determinant of C not will be equal to 0. So how you will check that whether it is full rank or not? Now determinant of C, okay, that controllability matrix will be not equal to 0, then only it will be full rank. Okay, so now so this will be the C matrix, and then you see T. If you want to build the T matrix, you have to multiply, or you have to find out the two matrices, that is C and M. C will be the controllable matrix which is given, and M matrix can be formed from the given characteristic or computed characteristics equation. So whenever the A matrix will be given, okay, whenever the A matrix will be given to you, then from there you can find out Si minus A determinant, and you can find out the characteristics equation, and then you can identify the coefficient of S, and from the coefficient of S you can find out the M. Okay, so M will be A n minus, you will start with the A n minus 1, A n minus 2, then A1 1, then you will, second row will start from A n minus 2, so A n minus 2, A n minus 3, then 1, then this element will be 0. So like that you will last the last row will be 1 0 0 0. Okay, so this way you have to build the A matrix. Now once you will get the A matrix, then you can find out the T matrix, and then what you have to do now, you have to do find out the A bar, T inverse AT, you will get this form definitely, and B bar, you have to get the P bar, you have to do T inverse B, you will get this form, and to compute the C bar you have to do C into T. Okay, so this process we have shown by an example. What is that example is, suppose this is a system is given where A is a 3 by 3 matrix, B is this, and C is this, and you see it is not in a controller canonical form. Okay, so it has been asked that the relation is to be transformed to controller canonical form. How we can do? Now just we have to follow the steps. First, what we have to do, we have to find out the characteristics equation of this A matrix. Okay, so we have found out the determinant of Si minus A, and we have identified what is A1, what is our A2, and what is A3. Okay, so now step 2, to build the controllability matrix. So controllability matrix for this case, it is 3 by 3, so it will be AB A to the power n minus 1, so n is 3 here, so 3 minus 1 is 2, so A square B. So you have to calculate, B is already given, so first column you see 1 0 1, so second row if you want to compute, then you have to multiply A into B, so A into B, then A square into B, and then second column and third column has been formed. Here one thing I want to tell you, that you have to use your calculator. Scientific calculator can do the matrix multiplication for easily, so you have to find out that one, and easily you can calculate, or quickly you can calculate B square B. Okay, so now whether for this system controller canonical form transformation is possible or not, that you can identify by checking the rank of C, and you see rank of C is 3 because it is a non-singular matrix, so the system can be transformed in controller canonical form. Now we can build the A matrix. So A matrix will be, according to our definition, you see A n minus 1, so it is 3 by 3, so we will start A2, so that's why it is A2 A1 1, so second row will be A1 1 0, and last row will be 1 0 0. So now already from characteristics equation we have identified what is A1 A2 A3, just you will substitute and you will get the M. Okay, Now from our definition, tree is C into M. It will be C into M. Mind that it will be C into M. So now T will be equal to C into M. Already C we have found out, M we have found out. So it will be this. Now if you do the T inverse AT, okay, then A bar definitely will look like this, because and you see it is in a controller canonical form, and B bar will be 0 0 1 and C bar will be 3 2 1, whatever it will come. Okay, so this is the representation or transformation of the given system in controller canonical form. So mind that here it will be not S into M, it will be C into M. Okay, so that's all for the controller canonical form. Similarly, for a given representation, we can find out the observer canonical form. Okay, so observer canonical form will be useful when we will do the observer design. At that time you will find that the calculation will be extremely simple if the system is represented in a control observer canonical form. At that time you will find that observer design will be easier for you, and you don't know what is observer, so definitely we will discuss. Okay, so now the same thing, we have a realization. Can we build a T matrix such that above realization can be transformed to observer canonical form, and here it will be X bar, mind that. Okay, so now how the A bar and here I want to tell you that for the observer canonical form, if you can remember, they have the fixed A bar and C bar, but B bar is nothing fixed. Whatever by calculation it will come, you have to write. Okay, so that's why your A bar should look like this after doing this T inverse AT, and B bar is equal to T inverse B is not restricted to any form, but C bar is fixed, that is 0 0 1. And how this A1 AN minus 1 AN minus 2 minus A1 has come, they are the coefficient of the A's in characteristics equation. Okay, so you have to find out the characteristics equation. So now I will tell you how to build this T matrix. This is our desired result. Now only thing is that we have to find out this T matrix. How the T matrix? So here the same thing, we are not going to discuss that how this T matrix has come, only I will tell you the result, not the proof. Okay, so the step 1, build T. Here T will be M into O inverse. Okay, so now first you have to find out the O. So O here, the observability matrix, it is C CA CA square and C n minus 1. Here it will be capital C C A n minus 1, and this dimension of this matrix will be n cross n. How? Now you see, that is what we are telling, that the observability matrix will look like what? Now C, what is the dimension of C? Now 1 cross n. So it will be something like this. It is a row vector. Okay, so now A into C, so n cross 1, and it is 1 cross n. Okay, no sorry, so it will be actually C into A, so it will be 1 cross n, and it will be n cross n A. So after multiplication again it will be basically 1 cross n, so it is another row. So like that you have to continue C A n minus 1, and obviously it will be a row vector, and ultimately if you stack it, it will be a n cross n vector. Okay, so we did that one, and we have to construct the observability matrix, and M matrix is same like earlier, means for the controller canonical form. And you see the same thing we are going to do with an example. Suppose x dot equal to ax plus bu, y equal to cx. A, you see it is not in observer canonical form, b is also B is 101 and C is 110. Okay, so now what is our job? The state equation is to be transformed to observer canonical form. Okay, so now the same thing, we have to, in step 1 we have to find out the characteristics equation, we have to identify the coefficient of S, then we have to find out the observability matrix, and we have to show that observability matrix having full rank, and if it is full rank then only we can do the transformation, otherwise not. We will stop here. So now CS square we have calculated, and we have calculated the observability matrix, and we are finding the determinant of observability matrix is not equal to 0. So we can transform this system in controller observer canonical form, and we have constructed the aim like earlier. Now we have taken, or we have built the T matrix by multiplying AMO and taking inverse, and this is the result. And if you calculate the A bar, B bar and C bar, they will be like this, and this is, you see, in a observer canonical form. Okay, so this is the all about the how you can build the T matrix for the controller canonical form transformation and observer canonical form transformation. And here I want to mention that I want to again upload the same slides once again, doing the all correction. So this will be the my updated one. So this last slide what I am sending today, that you should save. Okay, so now this is all about the similarity transformation. So this is extremely simple one. So now here what we have learned, mainly we have learned the concept of similarity transformation. Then three things mainly you have to give emphasis, that how to build T matrix for the diagonalization, and the computation of e to the power at is also possible using diagonalization. Okay, along with other uses of diagonalization process. Then we have understood that how to build T matrix for transformation in controller canonical form, and how to build T matrix to transform any realization in observer canonical form. Okay, so next I'm going to upload the assignment based on this. Quickly you have to submit, and here I want to mention you that we are going to discuss next topic is the core concept of this modern control theory, that is called controllability and observability. And after that we have to discuss the controller design, state feedback controller design and observer design. Then only our syllabus is going to be completed. Okay, so next be ready for assignment based on the similarity transformation. Thank you.